Hey everyone, so now we are going to talk about asynchronous JavaScript. So whatever code we have written so far were all synchronous in nature. What do I mean by this? JavaScript is a single threaded programming language, which means that the parser of JavaScript by default executes each line one by one. So let me give you a very simple example and this will all become crystal clear. So if I write console.log line 1 and if I duplicate this code multiple times, I will see line 2, line 3 and 4 and 5. You can pretty much guess the output by yourself. If I save this, you see we get line 1, 2, 3, 4, 5, right? So first this line was executed, parsed and then executed, then this and so on and so forth. So this is the default behavior of JavaScript. Being a single threaded programming language, it just has one thread in which the code executes, and all of these codes executes line by line. Now let me give you a very simple example problem and then it will all make sense. Now since JavaScript is a single threaded programming language and all of the code executes line by line, if I write an alert in between line 4 and 6, here if I just write I am a simple alert, okay, what do you think will happen? First of all, what does alert do? It simply alerts us a pop-up with this message, right? Now if I save this, then you will see that first these 3 lines printed and then we saw this pop-up, alert pop-up, and then these two console.log will not be evaluated to print line 4 and 5. So if I save this, focus here. Did you see first line 1, 2 and 3 printed and then now we saw this alert pop-up and now we cannot see line 4 and line 5. The reason is very simple. JavaScript is parsing all of the code one by one and then when the work is done, then it is going on the next line, which means first it parsed line 1, printed line 1, line 2 printed line 2, line 3 printed line 3, and then it executed this alert, which is a function which again is simply giving us a very simple pop-up window with this message. Now this pop-up window is not done yet, which means this is still in the work. Now how do we get rid of this pop-up? Well, by simply clicking this OK, because when we will click OK, then the program will be marked finish. Now when I will hit OK, now JavaScript was free from this line and the parser then moved to line 6 printing line 4 and then line 7 printing line 5. So this is a very simple problem of JavaScript. It is a single threaded programming language. Each line is executed one by one. Now you can ask me, then what is the problem? Well, the problem is, let me write the simple comment. The problem, now what is the problem? The problem is pretty simple. Let's assume we are developing Instagram for our local family members. Now they all want to upload photos of our family gathering. Let's say that their photo has different sizes. These photos are 1 MB, 2 MB, 3 MB, 4 MB and 5 MB in sizes. Now if by mistake they uploaded the 5 MB photo size first, then after that if they try to upload this 1 MB, 2 MB, 3 MB or 4 MB photo size, then these all photo, even though they are less in size than 5 MB, these all file sizes will have to wait before this photo is processed uploading. So here I can say 5 MB photo size is uploading, and I can say 4 and 7 and 2 and 3. I'm going to ask you a very simple question. Which photo do you think should be uploaded first? The photo with less file size or the higher file size? Of course the less file size, right? But if you pushed mistakenly, even though if you pushed mistakenly the 5 MB photo size to be uploaded first, after that even if you try to upload a photo with slightly lesser MB than the first one, which is of 1 MB, it will have to wait. It will have to wait for whatever seconds until the 5 MB photo is finished uploading. So this is the problem. You see that this is a very simple task. 1 MB photo will, let's assume that it will take 4 seconds to upload, and this photo will take 30 seconds to upload. I'm just assuming, okay, 30 seconds or 30 seconds, let's say 20 seconds to upload. Now again, it doesn't make sense that this 5 MB photo should be uploaded first, then these two lesser file sizes will have to wait just because this 5 MB photo is taking 20 seconds to upload. Okay, so this is the problem of synchronous JavaScript. If you write a program on line 12, it doesn't matter if it is going to take 30 seconds or 30 days or 30 months. Until and unless this program is finished, the parser will not move to the next line to parse it. Now there is a way to solve this, and that way is understanding how to write asynchronous code. Now asynchronous JavaScript is not a feature in JavaScript. It is just some set of rules and methods. How we use these set of rules and methods to write code in such a tweaking way that it makes our code asynchronous in nature, because by default all of the code are synchronous. If I save this, you see, of course I'll have to click OK. 5 MB photo size uploading, 4 1 2 3. Okay, so again everything is synchronous, so we will have to write this code, we'll have to tweak this code in such a way that it will make sense to upload a photo with lesser MB size first and then the higher MB size later. Okay, or why not all the photos can upload at the same time as well, depending on the data speed, the flow of data, how it is uploading on the server. Okay, but again, this is the very general example of what is the issue with JavaScript. Now let's say that I want to solve this. Now let me mimic a very general solution of this problem, and then we will move forward to understand all of this in little bit depth. Okay, now let's say that I want to fix this problem. I want 1 MB photo to be uploaded first, and then 2 MB, 3 MB, 4 MB and 5 MB, so in ascending order. How can I do that? We can do that, we can mimic this solution using this set timeout function. Now set timeout function is a part of window object. Okay, now set timeout function in itself is not a part of asynchronous JavaScript. This is just a browser API tool that is given to us in the JavaScript to mimic a certain delay. Now let me write the code and then it will all make sense. So you just have to call set and then time out in an uppercase way, actually camel case way. Okay, and then call it. Now this set timeout function takes two parameters. First is a function like this, let's pass an arrow function, and then here you'll have to pass a time delay. So here I'm just going to pass, let's say 10,000 milliseconds, which is equivalent to 10 seconds. Okay, now whatever code you will write inside, that code will execute after 10 seconds. So this set timeout function after 10 seconds will call this function. So whatever code you'll write inside this function, it will automatically be executed after this time expires. So here I'm going to write process of, let's say 5 MB data, 5 MB photo uploaded. Okay, let's assume that 5 MB photo takes 10 seconds to be uploaded. Okay, similar to this I can again call it, and now I can say 4 MB photo uploaded and it took us 8,000 milliseconds, which means 8 seconds. And I can again do this for 3, and this time it is going to take 6 seconds. And let's say for 2 MB photo it will take 4 seconds. Okay, 4,000 milliseconds. I'm going to comment these codes. Let's use multi-line comments and asterisk slash. Okay, good. Now let me tell you what will happen. See, first this set timeout function will print this, because 4,000 milliseconds will be evaluated first. Why? Because again I just told you that when the time will expire, then this code will be executed. So which comes first? Again 4 seconds comes first, right? So by the time this 4 seconds will be done, this callback function will be executed, printing 2 MB photo uploaded, and then 3, 4 and 5. So if I save this, I'll have to press OK to get rid of this simple alert. Now see, after 2 seconds, 4 seconds, 4 seconds, not 2, 4 seconds, 2 MB photo uploaded, 3 MB photo uploaded, 4 MB photo uploaded, and now 5 MB photo uploaded. Now this is asynchronous JavaScript. Even though our file is 5 megabyte of size, we are not waiting for this photo to be finished so that we can proceed to upload the 4 MB photo. We are simply saying that when the right time is there, just execute the function. Again, I'm just mimicking this, okay? So this is asynchronous JavaScript. This 2 MB photo, when it is lesser in size, it uploaded first, and then 3 MB, 4 MB and 5 MB. So this is a very simple example of asynchronous JavaScript. So let me give you one more example. I'll say console.log, I'll say start, and after this I'll say end, and here I'm going to write set timeout. Here I'll say console.log, say I am printed after 4 seconds, and here I'll pass 4000 milliseconds, and then after that again I'm going to pass set timeout. I don't know why I wrote it again. I should have simply just pressed command shift alt arrow. Let's do this one. It's shift control down arrow, okay, or shift option down arrow, okay. Now here I'm just going to write 0, which means not waiting at all. 0 seconds simply means not waiting at all. And when you are writing 0, you don't have to write 0 0 0 0 4 times. You just have to say 0. Now I'm going to pause these all code because I want to give you a homework. Now this is a very simple example that I have written here. I have commented all of the previous code above, okay. Now I want you to pause the video and try to come up with the answer. What do you think will be the output of this simple code? Now I just want you to pause right now, and after 2 or 3 seconds I'm first going to evaluate this code, and then I will show you the output, and then I will explain that, okay. So pause the video now. So I hope you were able to figure out the solution of this code. Now let me show you that what will be printed. So first this start will be printed because of course the script is starting on line 34. All of the previous code has been commented out. So here start, and then after this start, what do you think will be printed? We know that this set timeout function delays the execution for this provided time frame, which means this 4000 milliseconds, which means that this code will be printed after 4 seconds, and now the execution will move onto this set timeout. Now since we are not waiting at all, because 0 seconds is not waiting at all, so you may think that after that we are going to get this console.log I'm not waiting at all should be executed quickly. So you may think that we will get I am ... okay, and after that we will get this end, so end, and after that we will get this I am printed after 4 seconds. I am printed after 4 seconds. If you think so, you are wrong. The reason you are wrong will be discussed in the next video, but now let me tell you the answer. The answer will be this start. First the start will be printed, and after that we will get this end, and after this end we will get this statement here, and then after that we will get I am printed after 4 seconds. If I save this, let me separate this code as a wrong, right, okay. Now if I save this, you see start, end, I am not waiting at all, and after 4 seconds I am printed after 4 seconds. Start, end, I am not waiting at all, should be executed quickly, and then I am printed after 4 seconds. Why are we getting this output? See, we are not waiting at all. We are simply saying that hey, set timeout, print this line, execute this function after 0 seconds. So if we are not waiting at all, then why? See, here we are waiting, but here we are not waiting at all. So if we are not waiting at all, then why are we not printing this set timeouts code first and then the end? Instead, we are printing a start first and then end first, and then our execution is moving to this set timeout and then eventually printing the line that is waiting for 4 seconds to be printed. Well, the reason is pretty simple, but that pretty simple reason will be discussed in the next video, where we are going to see all of this with a very simple and neat presentation of what is event loop, what is the role of callback queue, which is also called as message queue, how does execution actually happens in this code, and we'll understand about web APIs as well. Okay, so yes, see you in the next one. Again, take it very simply, try to manipulate this code on your own, and all of this will make sense. Okay, I'm just taking it very slow. These are very simple to understand. Okay, so I've really put a lot of emphasis over and explaining how these codes actually works. That's why I'm talking in a really slow way. Otherwise, I put a lot of editing into my videos, but this time I'm going to keep it as much raw as I can. Okay, because this is really very confusing concept. Asynchronous JavaScript is really very confusing. It is not tough, friends. It is not tough, not at all. It is confusing. It's the things like execution context, call stack, message queue, event loop. How does all of this interacting together to print whatever the output it just printed? So if you understand all of this, come on, you are going to master JavaScript. This is the reason why I first talked about how does the JavaScript's internal actually works. I could have simply taught you that, hey, this is asynchronous JavaScript, this is the work of asynchronous JavaScript, but then I realized that no, this is not the correct way. I should first get into the details, as much details as it is required for you to understand, like what is execution stack, call stack, how does all of these works, and then I should talk about asynchronous JavaScript because these are connected. So in the intro I told you that all of the lectures are built upon the previous knowledge. So now all of your knowledge is going to be utilized in the next video, where we are going to see this neat presentation. In this video, the goal is to explore the internals to get a better understanding of what exactly is happening. I recommend watching this explanation twice and then drawing the execution stack of each function call with hand on a paper. This way, you will have a lot of exposure to various forms of asynchronous programming, and it is going to reinforce and reinstall exactly what is happening behind the scenes. Now we are going to start off with a little visualization of understanding how our code is executed and what are the roles of other properties like event loop and web APIs. So let's dive in. Right here we have our first of 3 examples that we are going to look into. Now even for a very simple synchronous example like this one, there is still quite a bit going on. So let's take a moment to break down what we are saying here. At the top left, we have the JavaScript code that is executing. So this is our very simple script. We created a variable and we print a message to the screen. Down below, we have the terminal output for that script. So as the script prints something, that will show up down here. On the right hand side, we have all the internals that are running behind the scenes in the engine. We have the call stack, the web API, our callback queue, and our event loop, all of which works together to get our asynchronous programs running. Now for simple synchronous examples like this one, the only of these 4 we need to worry about is the call stack. So let's take a moment to start there. Now remember, I told you that the call stack is a simple data structure provided by the JavaScript engine. The only job of the call stack is to track the execution of our program, and it does that by keeping the track of all of the functions that are currently running. The first thing that is going to happen is that our script is going to get wrapped in the main function, which starts the execution. Now something, when it gets added to the call stack, it means that it is going to execute. So the engine is going to start parsing our code from here on line 1. Here we declared a constant x with the value 20, and then we go ahead and declared a constant y with the value of 30. Then we move on and do a simple console.log of x plus y. Now console.log is indeed a function. So remember, I told you that each function call gets its own execution context in which the code it has defined are stored and executed. So right here we are going to get console.log pushed onto the call stack. So now we have the main function and we have the console.log. Now once console.log is dropped onto the call stack, that is actually going to run and we are going to see the value show up in the console. We would get sum of 50 printing in the terminal. Now when a function is done doing its job, it gets removed from the call stack since it is no longer executing. So at this point this console.log has done its job of printing something to the console. It is now going to finish by getting removed from the call stack. From here we do not have any more code to execute, so we mark the program finish, which means our main function is going to finish as well and going to be popped off from the call stack, and now we are left with an empty call stack. At this point our program is done. Now this is just the first basic example to get comfortable how the call stack is going to work. Although we have already seen how this works, but I made sure to show it once again with the example in the context of asynchronous programming. The next example is still a synchronous example, but there is a bit more complexity with multiple function calls. If we take a brief look at the script, I can see I have defined a print all locations function that takes an array and for each location it loops through it and prints it to the terminal. Down here I have defined the array and passed it to the function. So let's see exactly how things would run when we run our script. The first thing that happens is the main function gets pushed onto the call stack that allows the script to start executing. Right here we have defined the print all locations function. Now at this point we are not calling the function, so it is not going to appear on the call stack. The next thing that happens is the parser moves onto the line where we have defined the locations array, and after that we call the function by passing the location array. So this is a function call, so we will see print all locations getting added onto the call stack, and here I have summarized the arguments value, so all fits in this nice block. So from here this function is the current execution context. Now the only thing inside of this function call is a call to the for each method. We are looping over each locations provided. So for each is indeed a function call, so again it gets added to the call stack, and I have ... in place of its true arguments, which is the function to run. This function is going to run one time for each location. It gets access to the individual location and it prints it. So that is the next thing that is gonna happen in the program. For each is responsible for calling this function multiple times. So the first time it gets called, it indeed is added to the call stack. Now what do we see here? We see that the anonymous function call with the argument patna, and then from there we actually call console.log, which is another function, so that gets added to the call stack as well. Now console.log indeed once again is going to print something to the console, so we will see that appear here in the console. Now console.log is finished, so that is going to get popped off the stack. And once console.log is finished, our little anonymous function is also done, which starts here and ends here. That is also going to finish since console.log was the only statement inside that function, so it gets popped off the stack as well. Now for each does not get popped off the stack because it is not quite done yet. So we are going to see a new anonymous function added to the call stack, and then from there we are going to see another console.log, this time printing Varanasi to the console, and then from there console.log gets popped off and the anonymous function call as well. Now at this point for each has gone through that process 2 times. There are only 2 items in the array, so for each is done and that's gonna get popped up the call stack as well. Now that for each is done, print all locations is also done, and that is the only thing that print all locations does. It just calls for each. When for each is done, the function is over. Now we are again back at where we were before, which means we are all done and the program is marked finished by removing the main function as well. The final result we have here is Patna and Varanasi printed in the console or terminal. So here we cleared the concept for how the call stack is going to allow us to work through our program, keeping track of the individual functions that are actually executing. Now let's go and move on to the third and the final example. This is our asynchronous example that we actually wrote out and ran in the last video. And now we are going to explore how it ran behind the scene, so we can figure out why we were seeing things in the order in which we were seeing them. So since this example is asynchronous, we are going to use call stack, web API, the callback queue, and the event loop all working together to get our application running. Now with like our other synchronous example, again the first thing that happens is the main is added to the call stack that starts the execution of our program. On line 1 we have a log to the call, so the log is added to the call stack, we get the output in the console, and then it gets popped off the stack. Next we move to the set timeout function. Set timeout is clearly a function, so again something new gets pushed onto the call stack. Now set timeout is not part of the JavaScript programming language itself. You are not going to find out the definition of set timeout anywhere in the JavaScript specifications, and the JavaScript engine has no implementation for it. Instead, it is the browser API that creates an implementation of the set timeout using C++ and provides it to the JavaScript to use. Executing set timeout actually calls out to the code that is not part of the JavaScript. It's part of a web API which the browser provides for us. Set timeout is then finished executing while the web API waits for the requested amount of time. As we saw, it is the asynchronous way to wait for a specific amount of time and then have a function run. So when we call the set timeout function, it is really registering an event with the browser API, and that is an event callback pair, where the event in this case is simply to wait for 4 seconds and then the callback is the function to run. Another event callback pair might be to wait for a database request to complete and then run the callback that does something with the data. So right here, when we call this set timeout, a new event is registered in the web API. Here we have our set timeout waiting for 4 seconds. Now at this point in the process, that 4-second clock starts ticking down. While we are waiting for that 4 seconds to happen, we can actually do other steps inside of the call stack. So JavaScript itself is a single-threaded programming language. You can do one thing at a time, and the call stack enforces that. We can only have one function on the top of the call stack, and that is the thing we are doing. There is no way to execute two things at the same time. Now that does not mean JavaScript process is completely single-threaded. The code you run is still single-threaded however, but JavaScript uses other threads in C++ behind the scenes to manage your events. That is what allows us to continue running our application while we are waiting for those 4 seconds. Now from here, we move on to another set timeout. We call set timeout again, and it is again going to register yet another event in the browser API where the event is 0 seconds, and at this point we have now two web API callbacks waiting in the background. So we can still continue to do other things while both of those are waiting for the event to complete. In the first case 4 seconds, in the second case 0 seconds. Now where do we go from here? While the 0 seconds are up, so this callback needs to execute. Now how exactly does that happen? Well, this is where the callback queue and the event loop down below come into play. The job of the callback queue is simple. Its job is to maintain a list of all the callback functions that are ready to get executed. So when a given event is done, in this case when the 0 seconds timer is complete, that callback function, the function we defined right here, that is gonna get added to the callback queue, which is just a standard line. The code whose time is up and needs to be called first gets added to the callback queue for execution. Since there is no items in the list, the callbacks get added right up front. So we have this callback and it is ready to get executed. But before it can be executed, it needs to be added onto the call stack. That is where function go to run, right? Now this is where the event loop comes into play. The event loop looks at two things. It looks at the call stack and it looks at the callback queue. If the call stack is empty, it is going to run items from the callback queue. So at this point, the event loop says, I know you got added to the callback queue, but the call stack is not empty, so I can't execute you. And this is why our function does not run right away, even this is executing just after 0 seconds. which means not waiting at all, right? The event loop needs to wait for the call stack to be empty, but at this point main is still running. So the parser moves and executes this log, which again gets stacked on the call stack and then logs the value in the console, and after this is done it gets popped up from the call stack and the main function is done. So from here program is marked finished, so the main gets removed as well. Now with our regular synchronous scripts, this is when the program actually finishes. The end of main signifies the end of the application. This is not the case with our asynchronous program. Right now the event loop can start to do its job. It can see that the call stack is empty and it will check if it has anything in the callback queue to push it to the call stack. It certainly has, so it takes that item and moves it to the call stack so the callback can run. So at this point our callback function is running, that is going to execute the function right there, and here we just have a very simple console.log, which then again prints a message in the console and then it gets popped off the call stack and the callback function is also done. So this is why we are saying I am not waiting at all after start. None of our asynchronous callbacks are even going to run before the main function is done. So at this point the program is still not done. The call stack is empty, the callback queue is empty, which means the event loop can't do anything. The program just waits there for 4 seconds, and after 4 seconds our other event is done and it gets added to the callback queue. Now again the event loop notices that the call stack is empty and a callback is waiting in the queue to be executed. It takes the callback and pushes it to the call stack. Now here we again have a log that gets added to the call stack and then prints the message. Now it is done, so it gets popped off the call stack and now the callback is done. And at this point the program is complete. The call stack is empty, the callback queue is empty, and there are no events registered in the web APIs. This means the process would be complete, and over here we have the exact same output we got when we actually ran the application. The only difference is that now we know why we got the messages printing in the order we saw them. It is because JavaScript behind the scenes uses other threads to execute the code, allowing end message printing first, even though we are waiting for 4 seconds for our other messages to print. We also learned why we were seeing end printed before I am not waiting at all. That is because the event loop can't run any of our asynchronous callbacks until the call stack is empty, which means the main needs to finish first. Now this is a really cool technical details, and if you know about this, then you are already miles ahead from those beginner JavaScript developers. And actually I can say that sometimes many experienced JavaScript developers have tough time understanding the execution of the JavaScript, even though the mechanism of execution is fairly simple. Okay, now I made you an expert, so make sure to like and subscribe the channel, and let's now understand how to write asynchronous JavaScript code. If you really want to become good in JavaScript, then a part of JavaScript is to understand how to write asynchronous code. So how to write non-blocking code that does not block other codes from execution. So here I have a very simple example. I have given a task to design a user registration system. Now the steps are as follows. First, the user needs to register. We are going to provide them a form, and then when they will provide their email or maybe mobile number, we are going to send an OTP, and then they will be able to log in, and then we are on the server going to fetch their data from our server and then display the user. We are going to render the view. So the process is fairly simple. So here I have created 5 functions. Register user, where I have simulated that registration form field, and then we have send OTP, one-time password sent. Then login, user was logged successfully. Then we got the user data. It should have been get user data and get user data, and then we build the view and then we displayed the user. Okay, and then we are calling all of this in one by one. So the steps needs to be completed in the order which it is written here. So, and of course that's how you design a user registration system. So first you provide them a form, then send them an OTP, and then let them log in, then get their data and then display their view. Okay, So pretty simple and straightforward process. Now after all of this code is executing, you can see that other application work is also happening. Now these works can be different, loading suggested profiles to follow, or then maybe displaying the user posts from their favorite artists whom they have subscribed, right? So these are also some tasks. Now if I save this, let's see what happens. Okay, registration form filled, one-time password sent, user logged in successfully, got user data, displayed user data, and then other application process is happening. Now there is a problem. Now all of this is a very good example of synchronous JavaScript in which all the code executes line by line. So first we are going to provide the user a registration form which they will fill, providing their email address or maybe mobile number, and then we are going to send them the OTP, and then they will be able to log in. Then we are going to fetch their data from the server which they have provided while submitting the form, and then based on the data we are going to build a view, and then we are going to render them. Okay, so this is the process. This is a very simple process that happens when we build something like this user registration system. Register, we are going to send the OTP, you will be able to log in, we are going to fetch your data based on the data provided in the login form, and then we are going to render the view, right? Now the same thing is happening here. We are calling all of these functions in the same order: call register user, send OTP, login, user data, and display user. And when I saved all of the data, you saw it is coming in the form of coming in the order in which they were called. Now this is good, but there is a problem. The problem is processes like registering user, sending OTP, letting them log in, and then fetching their user data from the server, and then displaying the user. All of this process is a network request, and network requests can delay. So here I'm going to write network requests can delay. This is the reason why most of the time you will see, if you are logging into some websites, there will be an option of forget password or maybe resend OTP, because this is network request, and network request can malfunction. Sometimes the OTP can delay, or sometimes the OTP will totally fail to be delivered to the client. In this case we have these options like resend the OTP, or maybe you forget password, okay, reset it again. Okay, so this is the problem. Now how to solve this problem? But first, before understanding how to solve this problem, let's simulate, because I want to show you some more thing so that you can understand what is the problem here. Let's say that the register user network request failed for 3 seconds. So the form was displayed after 3 seconds. So here I'm going to paste a very simple function which you do not have to understand. We are just waiting. We are going to provide it a millisecond, and then the code will execute after the provided millisecond. So let's simulate the delay. Here I'm going to call wait. Let's say that this user registration form was delayed for 3 seconds, and same way the sending of OTP was also delayed for 3 seconds, and the login was also delayed for 3 seconds. The fetching of data from server was also delayed for 3 seconds, and same the rendering of view was also delayed for 3 seconds. This can be very much possibility depending on the maybe internet connection. Yeah, okay. So if I save this, let me tell you, all of this we are simply saying that hey, wait for 3 seconds before executing this code. So this code is the form that we are sending the user, which they will fill, and after that we are going to send the OTP. Okay, now if I save this, after 3 seconds you will see registration form filled, and then one-time password was sent, and then we say user logged in successfully, and now we see getting user data, fetching the data from server, and then displaying user data. Now after all of these processes are done, now other application processes is happening. Now this is the problem, why other application process needs to wait for these tasks to be performed first. Maybe these tasks are very important. For example, if you are watching someone's live broadcast and if you are commenting on their system, then if your comment is delayed, if you have network request, that does not make others preventing from commenting on the live video, right? But if you are able to comment, then your comment will be pushed once the network request is successful, right? So what is happening here? All of these tasks should not wait for these tasks to occur first. Other application processes needs to execute in the background, and then these code, when they will be ready, they will be completed. So this is the problem, because right now all of this is synchronous. All of the code is executed one by one, okay? And then when the parser comes here, they do all of this work. But this is the problem. This will become really difficult to manage to build larger web apps, okay? You can't even think of this. Now, how to solve this problem? That other codes will first execute, and then at the same time we are able to maintain the order in which the user's registration system will be built. Here comes callback. So the first part of understanding asynchronous JavaScript is understanding callback, okay? And I'm going to get rid of this. I'm going to comment this function because I just wanted to show you the problem. And let's delete all of these waiting code, okay? And let's delete this. Now let's simulate the delay. Let's say that this registration form is filled after 3 seconds, or maybe 2 seconds, or maybe 1 second, okay? Let's try to do, I'm just going to use this set timeout, because set timeout does not stop our code from executing, okay? By using this set timeout function, we will be able to fix this code, okay? Now here, okay, so this is the correct order, set timeout function. And of course, let's say that this form is coming after 1 second. Let's use the same set timeout here, and let's provide it here, delete this one, and then this will also come after 1 second, and then the same set timeout is coming here. Let's delete this. Again, this will also execute after 1 second, same set timeout. Let's get rid of this one, and the same thing is happening here as well, okay? Displaying user data after 1 second. Now if I save this, you will see that other application process is happening, and after that, when the time for our code execution comes, then we are sending all of this form. Registration form filled, one-time password sent, user logged in successfully, getting the user data and displaying user data. Now this is good. This is what we want, right? Other application processes need not wait for this code to be executed first, and then these will execute. These code will execute, and then when the time for this code execution will come, then this code will be executed, okay? So this is the solution. Now this is a solution, but this is not the actual solution, because let's imagine that let's say that this send OTP function, or maybe this registered user function, the form registration is again delayed. Let's say that this is delayed for 3 seconds. Now let's see what will happen. If I save this, you see one-time password sent, user logged in successfully, getting user data, displaying user data, and then registration form filled. This is absurd. We are sending one-time password even though the registration form was delayed for 3 seconds. And this will become really more confusing if you say that we have this OTP, send OTP, delayed for 4 seconds. Now let's see what happens. Wait a second, user logged in successfully. How? We are not even registering them, okay? And then how the OTP was sent? These two processes are delayed for 3 and 4 seconds, but now user was also able to log in successfully, and then we also fetched their data from the server. We displayed their data, and then registration form filled and one-time password sent, that is occurring after these 3 tasks. This is problem. So this is like a hack. We are using set timeout function, but still we do not have any control over how our data will be sent and how we are actually doing the tasks based on the code implementation. How to fix this problem? The solution is callback. Now callback is a very good technique through which we can provide a function that will be called after a certain thing happens. So here in this register user function, you just pass a CB parameter. You can call it anything. CB is short for callback. And then here we are going to just execute this CB function because this will be a function. Okay. Now here we are saying that, hey, set timeout. After 3 seconds, please call this function. So this function we are going to pass right here. And the function that we are going to pass this register user will be like this. So I can say, I can call it a user, I can call it a arrow function as well, but let's provide a very simple function expression. It's not a function expression, function declaration. So here I can pass these all 4 processes. Okay, let's take it here and let's paste it. So let me explain you what is happening. We are simply saying that, hey, register user, I have a callback, set timeout. First send this registration form, and after registration form is sent, then send this callback. So this callback is this parameter, which is this function, this entire function, which is executing all of this code one by one. So if I save this, now you will see that we are able to preserve the order in which our form needs to be called. If I save this, other application work, loading, building view, and then registration form field, user logged in successfully, getting user data, and then displaying user data, and one-time password send. Now again, there is a problem. This one-time password send should be coming after the registration form field. Okay, why this is delayed? Well, this is delayed because now we are waiting for this 4 seconds. Now how to solve this problem? To solve this problem, again we are going to use the callback. So here we are just going to pass this callback, and then we are going to execute this callback like this, and then we are going to pass this send OTP, this function, and inside this function we are going to execute all of these code. Okay, like this. Let's cut it here, paste it here. Now if I save this, now you'll see that we are able to solve the problem. So registration form field, after this one-time password was sent, user logged in successfully, getting user data and displaying user data. Okay, now if you say that somehow this login is delayed for, let's say, 3 seconds, if I save this, let's see what happens. So registration form field, now after one-time password was sent, now getting user data and then displaying user data, and user logged in successfully. Now we need to fix this one because now this set timeout is delayed. So again we are going to use the callback here as well. So here I can say CB, and here I'm going to say callback, and then we are going to pass this login, these 2 functions which are resting here. So let's cut it and let's now paste it, and now our order will again be preserved. The same way we can do the same thing here as well. So we can say call me back when your code is done. So here I can just provide it a function, and then we can pass this display user right there. And if I save this, now we are able to preserve the order in which our function is called. So registration form field, one-time password sent, everything will be in order. User logged in successfully, getting user data, displaying user data. Now if you increase the, let's say we are waiting for 8 seconds for this display user to be the views to be rendered. Of course this is going to work, but if I save this, let's wait. If we are here, so we must not really be in a hurry, we must understand everything. Registration form field, password sent, logged in successfully, getting user data, and after that it is taking 8 seconds to build the view, and now displaying user data. Okay, now all of this is good, we fixed the problem. Now if you increase any of the code's duration, you'll see that the order is still preserved. Let's say that this register user is waiting for 6 seconds. So the form is waiting 6 seconds, is taking 6 seconds to load. Before this function executes, none of these functions will execute. or I think this function will execute because here we have not used callback. If I save this, okay, you'll see registration form filled. So this code also did not execute because this is coming in the last. We are calling it here, user logged in successfully, getting user data, and after that, after 8 seconds we will display the user. So let's minimize this to 2 seconds. So this is how, by using callback, we are able to fix the code. So even though this function, or any of these functions, no matter how much time they take, other code will not execute before this code is executed. So we are again preserving the order, but there is a problem. Can you see? Is we are writing unmanageable code. We are writing wet code, which means writing everything twice. So here we are using a callback inside a callback inside a callback. So this part here that you are seeing, this is called as callback hell. So I can say callback hell. Now in this in programming paradigm in JavaScript, this callback hell is not suggested to be how you should make your code asynchronous in nature. Of course, we made our code asynchronous in nature. Other application processes are happening, and when the time for this code occurs, they executes, right? But at the same time we are using callback hell. So can you see this here, this design here? So let me show you this part here. This is actually called callback hell or pyramid of doom, and this is not suggested to do because of course this is very simple code, and that's how you can write this callback hell. But imagine if you have hundreds of processes that are dependent on previous processes to be done, then you'll have to include many callbacks, and then you'll have to call them plenty of times, which will actually make this callback hell look really sharp. So this callback hell will be becoming something like this, a very big pyramid of doom, and which is unmanageable, and this will really become at some point this will actually have the potential to breaking your entire code, because once certain changes and your entire code base will actually fluctuate. Okay, now we can solve this problem, the problem of callback hell, by understanding about something which is called as promises. So let's now first see what is promise. So I'm going to comment this part here. This is callback hell, and let's now see how to build promises. Promise is a modern way of writing asynchronous code. Promise was introduced in ES6 in 2015. Promise helps us to improve the code, and by building promises, we don't have to fall in this ugly pattern of callback hell to make our code asynchronous. Now, what is promise? Promise is an inbuilt JavaScript object, or you can also say it is a constructor that helps us to create an object that we have to return from a function. I will show you in a moment, but first let's go through more details and understand promise. So promise, as the name itself suggests, returns you a state that needs to be used. We know that asynchronous code executes in the background without breaking the thread, right? But when the code execution is done, then we need to return a promise and then use the state of that promise. Now let's understand all of this by writing few lines of code. So again, I copied all of the previous code and I repasted it. I commented all of the previous code, and here you have the example of callback hell. Okay, and somewhere here, right here. Okay, so this is the example of callback hell, and here we are going to understand about promise. So let's now see how to build a promise. Now as a developer, most of the time we don't have to build promises on our own. We just have to consume them. But since we are learning about asynchronous JavaScript, I found it really important for us to understand to even build a promise on our own. So here, to build a promise, you just have to return a new promise object. So just call promise with an uppercase P. Now this promise object accepts a function as a parameter. So I'm just going to make it an arrow function. Inside this arrow function, we have two parameters, which is resolve and reject. and now all we have to do is to take this set timeout and move it inside this new promise. Now let me tell you about this resolve and reject. Promise has few states. These are pending, fulfilled, and rejected. When you create the promise, initially the promise is pending. It is neither fulfilled nor rejected. So right now, promise is in pending state. Now, what does it mean for the promise to be fulfilled? It means that when the code inside of the promise is successful, then the promise is resolved, so it is fulfilled. And if the operation failed, then it is rejected, so we'll have to call reject. Now instead of calling this CB here, we now can call this resolve. Okay, so this resolve indicates that the operation inside of this promise is a successful. So now return the resolve. So this resolve will simply return this entire part here, so which means that our registration form will be shown to the user, which they can fill. If there was some error, then we just have to call reject. Okay, and not here but here. Okay, because we do not want this code to be parsed. But now let's call it resolve, because this code is executed successfully. Now this is creating the promise. Now when you create the promise, after creating the promise, after building the promise is the correct word. So this is building the promise. After building the promise, you have to consume them. So to consume the promise, you just have to take the function inside which you have actually build the promise. And I can see we have this callback here. I need to get rid of this. We are no longer using callback. So the function is a register user, right? So I can come here, I can say, I can call registered user function like this. And now to consume the promise, we have a dot then method. So if the promise is successful, we can call this dot then method, and then inside this dot then method we have this function in which we can get the data of this promise. So since this promise is successful, we can get the data of this successful promise right here inside this dot then callback function. So this data here, fulfilled data. Okay, but if it is rejected, then the promise will throw us an error. Okay, and so here, okay, but wait a second, we do not want to print the data of this successful promise. We can do that. We can say d, and then I can say console.log d. If I save this, what are we going to get? We are going to get registration form field, but then we are going to get undefined. And the reason is we do not have to call this function. We have to call we have to do something. We have to say that when registration of user is done, now call this send OTP. So here inside of this then method, which again accepts a function, I can call this send OTP function, and I don't have to call it, just pass send OTP, because this send OTP function will be called by this dot then method. Okay, and now if I save this, we are going to get into an error, callback not defined. Callback is not a function, so again get rid of this callback. Okay, and if I save this, now we get registration form fulfilled, registration form field, one time password sent. Okay, and after one time password, we have to call this login. So again we have to build a new promise inside of this send OTP function. So I can say return new promise resolve reject, and then let's take this code here and then make it resolve. Okay, and then we have to call dot then again. So this is method chaining, and then we just have to provide it login. So when this send OTP function is called, then it is going to return a new promise, which is this entire promise, which is again getting resolved. So the value for this resolve we have to catch in this dot then method, and then we are passing this login function. So let's get rid of this callback, and then again create a new promise here as well. So new promise resolve reject, and let's put it inside this, and let's make it resolve, let's call it, and let's do that here as well. Return new promise, resolve reject, and bring it inside, remove callback, and let's resolve this one as well. Okay, and now let's do the same here. So I can say dot then, so the promise that we are returning from this login function, we resolved it, so we have to call this get user data. Okay, so I can say, hey, now call get user data, and after this get user data we are also returning a promise, so this get user data is also fulfilled. So this get user data will actually resolve this display user. So here I can say, now you call this display user. Okay, so this is method chaining. We are saying that, hey, registered user, your promise is resolved, then call send OTP. Send OTP's promise is resolved, then call login. Login's promise is resolved, then call get user data, and get user data's promise is resolved, then call display user data. And you can see that the same thing is happening. So now if I save it, you will see the exact same output. Registration form filled, one time password send, you are logged in, and then getting your data and displaying your data. Okay, so this is promise. Now let me make it one more thing clear, is that if somehow this is resolved, which means that promise is fulfilled, what if there was an error? How to hold the error? So let's say that this registration user or this send OTP is unfulfilled, okay, rejected. There was some error sending the OTP. So now we just have to, instead of calling resolve, we have to call reject. So we just have to call reject, and then here we can provide the message. I can say error sending OTP, sorry, checking our backend, thanks for your patience, anything. Okay, save this, and now you have to return it from here so that the next line will not execute. Just have to say return, because return blocks the execution of the next line. You can see it is grayed out. Okay, if I save this, we will get registration form filled, and after that we get this error. If you do not return, if you return this after this console.log, then you are going to get this one time password sent, which again, since we are returning an error, then why are we even getting this message of one time password sent, and then we are getting this error? This does not make sense. So we have to just call return before this console.log. Okay, and now you see that we have this error. Now we definitely are getting this error, but we are not consuming this error. Now to consume this error, now we are definitely getting this error, but we are not consuming this error. So to consume this error, now we have one more method which is called as catch. So then is for resolve, if the promise is resolved. But if the promise is rejected, then we can call the data of that rejected promise in this catch method. And now here again we can pass a very simple function, and I can call it let's say error. First of all, let's save this. Okay, error, and here we just have to say cl error. Okay, and if I save this, you'll see that our error will be printed. It says error sending OTP, sorry, checking our backend, error in sending OTP. So always try to write clear message. Okay, the registration form filled, error in sending OTP, sorry, checking our backend, thanks for your patience. Okay, so this is how you consume promise. Now I'm going to ask you, which one do you think is easy as well as understandable to write? This callback hell, which can very soon become pretty cumbersome to manage, or this promise syntax? Of course, this promise syntax, right? See how clear it is. Everything is chained together. The data is built upon previous data. Everything is happening asynchronously, but this is more clear syntax than the callback hell. So let's now quickly resolve this promise. So instead of calling reject, I can comment this out and I can say resolve. I'm giving this code here so that when I will give you the final file, you can see this. Okay, now promises are good. Now we have more modern way of writing these promises in a better way by using async await. So let's now understand async await now, because this also makes our code look really more readable, as well as we don't have to depend upon building promises and then consuming them. By understanding async await, you will actually understand that why most of the time we do not build promises but we just consume promises. Now I made a very simple mistake. I should not have written this code in the very last. I should have written this code right here, because we are understanding about asynchronous operation. Okay, now after this we are having all of these other application processes, so you will see that our code will still work the same. You see, other applications processes are happening first, and then the code that was blocking the execution, whom we just fixed, making them asynchronous. Now after these processes, these code executed. Let's now see async await. Async await is a syntactic sugar over promises, which makes handling promises even simple. When you will use async await, your code will appear to be synchronous, but indeed they are asynchronous. So let's now use async await to improve the code that we have written using promises. So here I'm just going to declare a function. I'm just going to call it authenticate user, and then inside this function I'm going to await the result of these functions. Okay, so the first function is register user, so I'm going to use the await keyword, and I'm just going to say register user. Now you can see that we are getting a warning. So if you hover over await, it says that await expressions are only allowed within async functions, which means that if you are using await keyword, then the function inside which you are using the await keyword, the function needs to be an async function. So here you just have to make it an async function. And so this is how we actually make our code asynchronous in nature, because I just said that your code will appear to be synchronous, but indeed they are asynchronous. So they become asynchronous by using this asynchronous keyword that you have provided to this authenticate user function. So we are saying await register user, which means that execute this register user function, and after that we are going to await this send OTP as well. So first this register user function will be called, and after that we are just going to say await send OTP. So we can simply write the order in which we want our code to be executed, and all of these will be executed one by one. Okay, so this is the simple task of await, and then after this we are just going to await login, and after this get user data. So I'm just going to copy this await get user data and await display user. Okay, and that's it. And now if I save this, you will see our code will execute. Okay, we need to call the function as well, authenticate user. Let's call it, and now all of the code is executing line by line, one by one. Okay, now one thing you should always remember, that asynchronous functions itself returns you a promise. So all of these functions are nothing but a result of a promise. But no, you don't have to call something like return new promise. No, this authenticate user functions, since it is an async function, it will automatically return you the promise, and then since it returns you a promise, you can catch the data of that promise using dot then and dot catch. So here you can say dot then, and here we are just going to pass a callback function, and here I can say what, here I can simply say console.log all task executed. Okay, here I'm just going to give it thug life emoji, why not? Okay, and now you can see that when all of our code will execute, we are running into some error. What is happening? Okay, I need to wrap this like this. Now if I save this, all of our code will be executed, and then we will see, wait a second, we ran into some problem. It says getting user data, and after that all tasks executed, and then displaying user data. So let's see display user data. So there must be some problem in this display user function, and we haven't returned any promise from this display user function. Okay, so let's return new promise, an arrow function with resolve reject. Let's put this set timeout inside this and then just resolve this. Okay, and now if I save, now you will see the exact output. Did you see this? Now registration is done, one time password was sent, user logged, we fetched the data from the server and then displayed the data of the user, and after that we get all tasks executed. And now if somehow we get some error, we can catch that here. I can say error, and here we just say error, and I can say error. Okay, let's check this. Let's make this send OTP rejected. So from here I can just again uncomment this, and let's comment this part here and this one as well. And if I save this, we are going to see error in sending OTP, OPT, OTP. I hope you noticed when I was writing this return reject command. Okay, and again, registration from form failed, error in sending OTP, sorry checking our backend, thanks for your patience. Okay, so that's how we are holding our error. So we are getting the error from this login function, and the functions that are coming after this login function, they are simply not executing. Okay, now I'm going to ask you very simple question. Now you can see that we have used callback hell, we understood callback hell, we also build promises, we consumed them, and now we refactored our promised code into async await. I'm going to ask you, which one do you think is more readable? Of course, async await, right? So yeah, this is async await. Now I want to show you one more way of handling error, and that is by using try and the catch block. So I'm just going to cut all of this code, and try and the catch block is pretty easy to understand. You just open a try block where you want to try for the code. So try all of these code, try to execute all of this code, and if you found any error in this code, then catch that error right here in this catch function. Okay, and then here you can use that error to notify. So I'm just going to say error. Okay, so pretty simple. We are trying all of the code, and if there is any error, we are catching the error in this catch block. So here we are getting this error on the login function, so this is going to bring no changes. We get error in sending OTP, but wait a second, we get this all tasks executed. Well, the reason is we are checking for all of these code, we are not checking for error for this authenticate user. So if you want to check for if there was an error in this authenticate user function, then you can return a manual error inside this catch function. So here I can say throw new error, and then now you are going to catch this error in this block. Okay, now if I save this, you'll get registration form filled and then error at authenticate user from line 237. So from here you are actually catching the error that was inside this entire function. Okay, so this is try, this is catch for this try, and then this is checking error for this entire authenticate user function. So this is async await. Now one more thing I want to show you is, remember I just told you that whatever value we pass inside this resolve function, we receive them inside this dot then block. So inside this function's parameter, right? But if we are using this async await syntax, then where are we receiving the data for the resolve? So basically this entire await call is the data that is returned from the calling of resolve function. So let me show you. I'm just going to this, where should I do? Let's call it here. Okay, so here I'm just going to call this resolve with this data. I will call it successfully. Let's just call it successfully just call it success. Okay, good. And now to see this, we'll have to then comment this part, otherwise we'll not be able to see this. And then if I save this, we are not going to, we will see this data, but we will not see the success data because we really have not used that. Okay, so to use that, we know that data of the resolve call is inside this await registered user, right? So we can store that data into a variable. I can say message equals to this one, and now I can do this and I can use that message here. Okay, and then this message will be printed after all of these functions are executed successfully. So now if I save this, okay, refactored, okay, registered, OTP received, user logged in successfully, getting user data, displaying user data, success, and then all tasks executed. Okay, so this is async await. Okay, so this is asynchronous JavaScript. We started with callback, we understood callback hell, we solved that callback hell by creating promises and then by consuming that promises, and then we understood how async await can help us to write promises in a much more efficient way and handle them in much more efficient way. Okay, now I know as a beginner this may be going over your head, but trust me, you need to watch it at least 4 or 5 times and try to manipulate the code on your own. Merely watching me writing all the code and executing them, you are not going to understand anything. You'll have to code along. You'll have to understand how this await call is happening, which I have already explained. Okay, so yeah, this is async await, and let's now move forward for some ES6 steps. Do make sure to subscribe.